TFL, the language for truth functional logic, has certain limitations. In particular, the language is able to model only truth functional connectives. That means that a connective that is not truth functional cannot be adequately represented in TFL. So that raises an important question. How can we tell whether a connective is truth functional? In other words, how can we tell whether we can model a given connective in TFL? What I want to do here is to develop two strategies for showing that a given connective is not truth functional. And I will thereby focus on the connective necessarily and show two strategies for establishing that this connective is not truth functional. So here's the first strategy. In short, the strategy is find an input that delivers two possible outputs. How does that go? Well, let's start by reminding ourselves of what makes a connective truth functional. We said that a connective is truth functional if and only if the truth value of a sentence with that connective as its main logical operator is uniquely determined by the truth values of the constituent sentences. And that means that you can show that a connective C is not truth functional by doing three things. First, you need to describe a sentence S that has C as its main logical operator. Second, you need to describe two possible scenarios in which S has different truth values. And third, you need to pay attention to the fact that in these two possible scenarios, the constituent sentences in F and S have the same truth values. So that's a little abstract. Let's look at an example. The connective necessarily is not truth functional. And here's how we can show this. Consider the following two sentences. Atari is necessarily identical to himself, and Atari necessarily has kibbles for dinner. Both of these sentences contain the connective necessarily. We can represent the meaning of the first sentence as necessarily Atari equals Atari, and we can represent the meaning of the second sentence as necessarily Atari has kibbles for dinner. Now the crucial point here is that the constituent sentences in 1 and 2 have the same truth value. They are both true. Atari is in fact identical to himself, and he in fact has kibbles for dinner. Atari is my second cat. However, sentence 1 is true, assuming that it is impossible for Atari to not be identical to himself, while sentence 2 is false. Atari could in principle have something completely different for dinner, say a mouse or a rabbit. So this shows that the truth value of necessarily A is not a function of the truth value of the constituent sentence A. Given that we have here seen two sentences with the same truth value, but when we embed them in the context created by necessarily, the result is a sentence with different truth values. So this was the first strategy for showing that a sentence is not truth functional, illustrated by means of the example necessarily. Now there's a second strategy that in some cases may work better. The second strategy is, in short, to argue by a process of elimination. And it goes like that. First, you list all the possible truth tables that in principle could represent the meaning of the relevant connective C. Second, for each of these truth tables, you then argue that it in fact does not represent the meaning of C. And when you are successful at that, that shows that the meaning of C cannot be represented by a truth table, which means that C is not truth functional. Let's again look at an example to see how this works. So for example, if necessarily was a truth functional connective, we would have to be able to represent its meaning by one of these four truth tables. Why is that? Necessarily combines with one atomic sentence to form a complex sentence. Now we know that that the truth table for a sentence that contains one atomic sentence can only have two rows for the two possible valuations of that atomic sentence. And that means that there are just four possible truth tables for a sentence that contains exactly one atomic sentence. So in the first truth table here, we see that it could be that necessarily A is true when A is true, and true when A is false. In the second truth table, we see the claim that necessarily A is false when A is true, and false when A is false. In the third truth table, we see represented the claim that necessarily A is false when A is true, and true when A is false. And in the fourth truth table, we see represented the idea that necessarily A is true when A is true, and false when A is false. So if necessarily was a truth functional connective, these would be the four possible truth tables to represent its meaning. And now the crucial point is that none of these four truth tables in fact represents the meaning of necessarily. Why is that? Well, the first truth table is extremely implausible because it entails that necessarily A is always true. This truth table effectively tells us necessarily A is true no matter what the truth value of A is. But that seems clearly incorrect. As we just saw, necessarily Atari has kibbles for dinner is false, since he could eat something else. So this truth table does not represent the meaning of necessarily. Now the second truth table is implausible for exactly analogous reason. The second truth table tells us that necessarily A is false no matter the truth value of A. But there are some sentences of the form necessarily A that are true. So for example, necessarily Atari is identical to himself is true. So it is not right to say that necessarily A is always false. And that means that this second truth table also does not represent the meaning of necessarily. Now, when we look at the third truth table, this truth table may actually look familiar. So in particular, this is the truth table for not A. We've already seen that not A is false when A is true, and true when A is false. But necessarily A and not A clearly differ in meaning. And so that means that the meaning of necessarily A and of not A cannot be represented by the same truth table. And that means that this third truth table does not represent the meaning of necessarily A, given that it already represents the meaning of not A. Now let's finally look at the fourth truth table. This truth table in effect tells us that necessarily is idle. So it tells us that the truth value of necessarily A always is the same as the truth value of A. So we could, in principle, omit necessarily and just say A. But that seems false. So in particular, it is possible for A to be true and for necessarily A to be false. As we saw in the example, necessarily Atari has kibbles for dinner. In this case, Atari has kibbles for dinner is true, but necessarily Atari has kibbles for dinner is false. And so that means that this fourth truth table also does not represent the meaning of necessarily. And so the upshot is, again, that none of the four possible truth tables that may in principle represent the meaning of necessarily, in fact captures the meaning of necessarily. And so that means that the meaning of necessarily cannot be represented by a truth table, and that means that it is not a truth functional connective.